Every teacher has watched a student arrive at an answer that is completely wrong but strangely consistent. The mistake isn't random. It reveals a pattern of thinking that, to the student, actually makes sense. These are the kinds of errors that linger if they aren't surfaced and addressed. Traditional assessments often expose whether a student got an answer right or wrong, but they rarely show why the error occurred. Intentional error analysis assessments, on the other hand, are designed to make student thinking visible. They allow teachers to identify the misconception behind the mistake and intervene before it hardens into habit. MagicSchoolAI makes this process far more practical. By generating items that focus directly on common errors, AI can help teachers build assessments that don't just grade performance, but diagnose understanding. Imagine two students working on the equation -2 times the sum of x and 4. One student distributes the negative to only the first term, writing -2x plus 4. The other student multiplies both terms correctly, giving -2x minus 8. A traditional quiz would mark one student wrong and the other right. An error analysis item reframes the problem. It asks, which student is correct? Explain why. This small shift forces students to consider both answers, reflect on the process, and articulate their reasoning. Even students who make the original error are confronted with an opportunity to rethink it. AI can generate dozens of items in this format, targeting misconceptions across topics like fraction operations, integer rules, slope, exponents, and probability. Because teachers know their own students best, they can prompt MagicSchoolAI with specific requests, such as create 3 problems where students are likely to confuse adding and multiplying fractions, or write 2 questions where students often mistake median for mean. The AI can then produce draft items where the incorrect answers are not arbitrary, but mirror actual student thinking. Another powerful use of AI is in creating multiple choice questions with distractors that are intentionally designed to reveal misconceptions. In a standard multiple choice question, the wrong answers may be random or superficial. In a misconception-based question, each distractor corresponds to a common error. Consider a problem like dividing 3/4 by 1/2. A random set of answer choices might include numbers that don't reflect any meaningful student mistake, but an intentional set might include 1/2, reflecting students who multiply straight across, 3/8, reflecting students who divide numerators and denominators separately, and 2, which is the correct answer. When a student selects one of the wrong responses, the teacher can immediately see which misconception is at play. When teachers embed these kinds of items into quizzes and exit tickets, they transform assessment from a simple right or wrong tally into a diagnostic tool. Instead of merely saying a student is struggling with fractions, they can identify whether the issue is with reciprocals, common denominators, or conceptual understanding of division. That level of precision makes intervention far more effective. A meaningful professional development activity is to have teachers build a 5-question misconception quiz for a single unit. Using MagicSchoolAI, they can generate distractors for problems on proportions, exponents, or area formulas. Then, as a group, teachers can critique whether the distractors truly align with student thinking. Some AI-generated options will hit the mark perfectly, while others may feel artificial or unlikely. The discussion around these choices is as valuable as the items themselves, because it sharpens the faculty's collective awareness of how students actually think. The benefit of this approach extends beyond diagnostics. When students are asked to analyze errors, they also deepen their own understanding. Explaining why a wrong answer is wrong requires unpacking the concept in a way that simply getting the right answer never demands. This practice not only corrects misconceptions, but also strengthens metacognition. Students become more aware of their own processes, better able to monitor and adjust their strategies in the future. Over time, building assessments around error analysis changes the classroom culture. Mistakes stop being a source of shame and become opportunities for growth. When students see wrong answers deliberately included as part of a test, they learn that error is not the end of learning, but the beginning of it. AI accelerates this culture shift by giving teachers the tools to produce these assessments at scale, freeing them from the burden of writing every distractor and justification prompt by hand. The process is straightforward. Select a topic, use MagicSchoolAI to generate error-based items, refine those items so they reflect real student misconceptions, and embed them into existing assessments. Once those items are in circulation, they provide both students and teachers with invaluable information, not just about what went wrong, but about how to make it right. In the end, end, error analysis and misconception assessments aren't just another form of testing. They are a way of seeing into the minds of learners, understanding how they process mathematics, and guiding them toward more accurate and flexible reasoning. With AI, teachers can build these opportunities more often, with less preparation time, and with greater variety. The result is a classroom where assessments do more than score, they teach.